In this video, we will investigate the derivatives of the trigonometric functions sine and cosine. Their derivatives are given by the following property. The derivative of sine is going to be equal to cosine, and the derivative of cosine is equal to minus sine. And additionally, the functions sine and cosine are differentiable everywhere, so at any value that you would like. Now, is this something that we could maybe easily see from the graphical perspective? And I think the answer is yes. If we focus in on, let's say, the graph of sine, if we wanted to sketch its derivative, how we would go about this is we would first think, where is the tangent line horizontal? And the tangent line is horizontal at pi over 2 and 3 pi over 2. And that corresponds to where cosine is equal to 0. And if you look at what's happening, let's say, between pi over 2 and 3 pi over 2, from a very intuitive perspective, if you pick any point, the tangent line is going to have a negative slope, which corresponds to where the cosine is negative. To the right of 3 pi over 2, or the left of pi over 2, if you pick a point and draw the tangent line, it's going to have positive slope. And this corresponds to where cosine is positive. So from a graphical and very intuitive perspective, we can see, yes, it makes sense that, say, the derivative of sine would be cosine. Let's go ahead and apply these formulas to a few basic examples. Let's differentiate 3 sine x minus 2 cosine x. And what we are going to do is simply combine these new formulas with the old rules of differentiation we had. So the old rules of differentiation tells us that we can take the derivative of a sum or a difference and break it up in terms of the derivative of the first minus the derivative of the second. And when we break it up into two derivatives, the constants we see, the 3 and the 2, can be pulled out front. So this is 3 times the derivative of sine minus, and then the 2 pulls out, 2 times the derivative of cosine. And now is where we use our new formulas. The derivative of sine is cosine, and the derivative of cosine is minus sine. And since we see we have kind of this minus a minus in the second term, we should simplify this one more step. 3 cosine x plus 2 sine of x. Let's do the same thing here in order to differentiate sine squared. And the first observation is that having sine squared is maybe not the most convenient thing to differentiate, at least in that form. So before differentiating, let's write it more conveniently. To square a quantity means you take the quantity and you multiply it by itself. So sine squared is sine x times sine x. And now we have something we can work with from a differentiation perspective. You see a first function f and a second function g. So we can go ahead and apply the product rule of differentiation. And I'm going to simply just write out what the product rule tells us, and then after writing it out, we'll evaluate the remaining derivatives. So the product rule tells us that we take the derivative of the first function, so the derivative of sine, times the second function, plus the first times the derivative of the second. So in this case, both derivatives we have to evaluate are exactly the same, and the derivative of sine, our new formula, is cosine. So this becomes cosine times sine plus sine times cosine. And note the order in which we multiply two terms, let's say cosine sine, sine cosine, does not matter. So what we are really doing is adding together two of the exact same term. So it's 2 sine x cosine x, which would represent the derivative. But just as kind of a reminder, this is familiar looking from a trigonometric identity, the double angle formula for sine. Sine of 2x is equal to 2 sine x cosine x. But I think either of these would certainly be acceptable values for the solution.